Hello and welcome to your next video for data analysis. This is going to be a part one of two since we have a lot to cover over this next couple of sections. First, we're going to start with interpreting and drawing conclusions from visual representations of data, meaning we're going to look at the different types of data, look at graphs, and do some reading of those graphs so that we can answer certain questions with the data that we're given. Now, there are two types of data. There's qualitative and there's quantitative. Qualitative consists of values that can be placed into non-numerical categories. And then we have quantitative data, which represents actual counts or measurements. And we're going to use some charts here where we're given information and we'll answer some questions with that given information. So let's look at this first chart. This is a chart that's given us different countries with the total annual CO2 emissions. And then it gives us the per person annual CO2 emissions. Now, what is the question we want to answer from this graph? Well, the first question says, what percentage of CO2 emissions is China emitting? Okay, so the question is what percentage? Now we can see the number, right? But they want to know the percentage. Now remember, as we've talked in the past, percent has to do with that part over the whole. What is the part in this case? That would be the emissions from China. What is the whole? That would be the all of the total annual CO2 emissions, meaning what we would want to do is we'd want to add this whole column because we're going to need that total, meaning you're going to add all of these up together so that we can figure out what is the whole in this particular data. So if you add all of these numbers up, you get 23,000. Now we can answer the question because the question says, and let me just slide this up just a little bit. The question says, what is the percent of emissions from China? Well, that would be China's emissions, which is 10,200, divided by the whole, which is out of a total of 23,000. So now we're still using that finance chapter section, aren't we, with the percents and the decimals. Put this in your calculator, and we get roughly 0.443, which remember as a percent. You either move the decimal 2 places to the right or multiply by 100. You'll get to the same answer, but 44.3% would be our answer for this particular question. Now the second question says, what percentage of CO2 emissions is the United States emitting? Okay, well, we already know the whole, so we got that. So we're going to go back up to the United States. That's going to be this number right here, the 5,300. All right, so now we're going to say 5,300 divided by 23,000. And so put that into your calculator, and we get about 0.23, which is roughly 23%. Now let's go to example 2. Now we're going to learn on reading a pie chart. Now we've already done a little bit of this in the finance video that we did on percents and decimals, but now we're going to apply this reading some data. So if 20 students were surveyed for the grades below, how many received a B in the class? Well, let's look at this chart. We know that for a B, and let me just come over here, we have 28%. Right? So we've got 28% in our circle. That's how many of the 20. Now remember what the word of meant. We multiply. So we take the 28%, but remember when we put that into an equation, we change that to a decimal. So the 28% becomes 0.28. Divide by 100 or move the decimal 2 places to the left to get the decimal. Out of 20 students in all that were surveyed. So we're going to take 0.28 times 20, and that gives us 6. In other words, 6 students, right, received a B in the class out of the 20. All right, we're going to go down to the next example, which is example 3. Now, this one is showing us the median annual earnings of full-time workers aged 25 and up by educational attainment and gender. What this is showing us is just the different median. Remember, we talked about that. It's like the middle number of all the data. And this is for full-time workers. And if you notice in the chart, it's split between men and women. All right, now let's see what the example is asking us, or the question. It says, what is the percentage difference in earnings for men with a master's degree compared to women with a master's degree? All right, so I'm going to just slide this up for a minute because I want to just write kind of a formula down here. We want to find the percentage of the difference for the men with a master's compared to women. So that means what we're going to take is we're going to take the men's salary minus the women's. And then we want to divide that because we want to compare it with the women. So that means we'll divide it by the woman's salary. Okay, that's basically what our formula would be. And now we have to look at what it said for the master. So let me go back up here. Oop, let's see. Master's, of course, is up here. All right. So we have right over here, let me just kind of circle the numbers. We have right here is the master's degree for men. So that would be 100,556. And then for women's, it would be 70,814. Those are the two numbers we're going to subtract from each other, but then I'm going to divide by the 70,814. All right, remember those numbers. So let me just go back to our formula that we wrote here. All right, the men's salary was 100,556. And then minus the women's, so that would be 70,814. But then we want to divide that by the women's, because what we're doing is we're comparing with the women's. All right? So that's going to give me, so subtract the numerator, that's going to be 29,742. And we're going to divide that by the women's salary, which is the 70,814. That's going to give us the percent that we're asking. Okay? So let's just say we round to the nearest hundredth. We should get about 0.42, which if we're asking as a percent would be 42%. Now let's look at the next example. This is a chart that shows the U.S. drug-involved overdose deaths for all ages, and this is from 1999 to 2019. And you can see it shows the different colors and what each color represents. The first question says, what type of drug was the leading cause of overdose deaths of 2019? So in this case, we're looking for 2019, which is right here. Okay, so that's the year 2019. And we want the one that has the highest. Well, that's going to be in our chart, which is the highest in height. That's here. So we have to look up that color, and that color would be the synthetic opioids. And that would be my answer. So let me just kind of slide this down a little bit. That's it. So that's all we're looking for that one. Now, the next question is going to take a little more work. That was our easy question. We're going to slide around a little bit because I got to go up and back to the chart. What was the overall percentage change in overdose deaths that involved cocaine from 2010 to 2019. Now, again, it's talking about percent change. So we're going to kind of apply the same formula that we did in the earlier one when we were looking at men's salary versus women's. This time we're looking at the overall percentage change in just the cocaine from 2010 to 2019. That means we're going to want to find the percentage from 2019 to 2010 and then divide that by 2010 because we're going to take the latest year minus the previous year divided by the previous year, kind of going back to when we were looking at percent of change in the finance video. So we've already done this similar, but we just haven't read the charts to do this. All right, well, let's find it. Now, here's the issue. Okay, we're going to look for this color. Now, the issue is we're going to have to estimate or guesstimate in a way. You can't quite see the exact numbers on this chart. So we can estimate what we think it would be. For example, if we look at 2019, now here's the color, this kind of like orangish color is what we're looking at. It goes right here. So this is the number we're looking at, right where you see me circling. If I go across, it looks like it's just over 15,000. This is where you're going to make some guesses. For example, I might say that looks like it's just under 16,000. So I'll say 15,900. You might have said 15,500. It just depends on where your eyes are going to be seeing this. But to me, it looks like it's almost at the 16, but past the 15. That's going to be my guess. Then we look up the number for 2010. Well, 2010 is right here between 2009 and 2011. Now, it's very difficult to probably find this. And if you want, you can always, when you're doing your homework, kind of zoom in on your screen. But if we're looking for that orange line, it's like right about there. If you can see me circling that. Where is that? Well, if I go straight across, it's just under the 5,000, maybe a little bit more below 5,000. So I'm going to say 4,200. Again, you're just going to have to estimate. If you're doing your homework, show me what you estimate it to be, because if the program marks you wrong, I will give you credit. I just need to see what you wrote down for that. All right, so now we divide by the 4,200. That means you're going to take the 15,900, right? And subtract the 4,200. That gives me, lost my place, 11,700. And then you're going to divide that by the 4,200. All right, well, I get about 2.8 if I round. Now think about what that means. Multiply by 100 to turn that into a percent. That's not your percent. It's not 2.8%. That's our decimal. You have to multiply that by 100. We get 280%, meaning the overall percentage change in overdose deaths from 2010 to 2019 was 280%. All right, that is our graph or our charts when it comes to reading data. Now what I want to do just real quick is go over some sampling techniques, because we've been talking about misuses of statistics with this whole chapter. So what is statistics? It's basically the science of collecting, organizing, analyzing, drawing conclusions from data. And we also use it to help us make predictions. And that is where we use the field of statistics. And we have two types of statistics. Descriptive is dealing with the collection and organization of the data that we have. In other words, if you have a bunch of data you collected, you organize it. You can show visuals of it, like what we just saw in our previous examples. That's your descriptive statistics. It describes the data. Inferential statistics helps us make predictions or generalizations using the given data that we have. So you've seen polls, for example, the presidential polls. Though that's not obviously we're not polling every single American. What they do is they take some polls of a group of people, and then using that data, make inferential, inferences from that. We also have what's called a population, which is like the total group we're looking at. But then there's the sample. We call that the subset of the population. And that's the sample that we're using to get the data. Sometimes you can't actually look at the entire population because it's just too many people. It always depends on what you're looking at. If I wanted to just study this class, then I could easily look at the whole population because we probably have less than 30 people to study. But if we're looking at 1,000, then we're going to want a sample of that 1,000. And here are the different types of sampling. There's random sampling. This is basically when you have a sample obtained in such a way that every element has an equal chance of being selected because you're randomly choosing people. You're not being biased towards it. It's very random. We have systematic sampling. Now this is in case, let's say you wanted to get an opinion on a movie, people coming out of a movie theater. This is just an example. And so you decide, I am going to ask every 5th person that comes out of the theater. This way, you're not being biased again. You're choosing every 5th person that comes out to interview them. We have cluster sampling. This is when we have a random selection of groups of units. Basically, you select a cluster sample. You divide, say, a geographic area, for example, into sections. Then you take those sections and randomly choose people. Stratified sampling involves dividing the population by characteristics called stratifying factors. So maybe you are splitting them up into gender or race or religion or income, whatever it is you're looking at. And then you take random samples of the class. That's what we call the class or the stratum. And then there's convenience sampling. This is taken from data that is easily obtained. So let's say you decide, I'm going to pull the first 10 people that walk out of a building, right? Out of building 7 on Valencia's East Campus. That's just a convenience sampling. You're just kind of picking the first 10 people that come out and then you're done with it. All right, now, given all of those types of sampling, let's identify which sampling technique is being used. Oops, don't know why it does that. Is being used with the given scenario. All right, viewers of the CBS network are classified according to age. A random sample of viewers from each age group is selected. So going back, that would be our stratified, right? Because we're putting them into some sort of factor, gender, race. In this case, it's age. So that would be what we call a stratified sample. 2, we just talked about this one. This one I think is the easiest one. Every 10th Samsung television coming off an assembly line is checked for defects. So they're not randomly selected, but it's every 10th. And what did we call that one? That was the systematic. When you pick a number, right? We talked about the movie theater, and I said you're going to pick every 5th person that comes out and interview them. That's your systematic one. Number 3, a state is divided into counties. A random sample of 12 counties is selected. A random sample from each of the 12 selected counties is then selected. Okay, so I kind of think of this in a way that, all right, so we took out this sample and we put it into clusters. That's how I think of it. 12 counties. We take a random sample of the 12 counties and then sample from there. That is what we call the cluster because we put everything in terms of some sort of cluster or region, and then we sampled from the clusters. Okay, number 4. a door prize is given away at a home improvement seminar. Tickets are placed in a bin and the tickets are mixed up. Then a ticket is selected by a blindfolded person, meaning what's happening here? They're just randomly selecting a ticket. That is our random sample. Last but not least, the first 30 adults leaving a theater are asked how much money they spend per week on entertainment. That was the last one we talked about. It's very convenient. We just have the first 30 coming out, you interview them, and then we're done. So that one was our convenience sample. All right, and that ends our video for part 1.